in this particular video, we have a uniform plank that rests on a level surface. It's just the plank itself. This dark brown plank here is 30 kilograms, and it says the length of that is 6 meters. So here the segments are broken up into 4.2 meters and 1.8 meters. Okay, and it wants us to find how much mass can be placed at the very right end of this plank, so before it starts to tip over. Okay, so before it starts to become unbalanced. So essentially, this is a static torque problem. That's because you're trying to find the critical point where it starts to tilt, meaning the system is still in equilibrium. It's that very critical value. Okay. All right, so I'm just gonna go ahead and put some unknown mass here at the right end because that's where it said so. So I'm gonna call that M because I don't know what M is. I'm supposed to find what that value is. So in order to do static equilibrium, identify the forces that causes the system to rotate. So here I'm just gonna go ahead and label this as my F of G. So this is F of G for the mass, some unknown mass. That's just mass times gravity. So I'll keep gravity as G for now. And then on the left side here, I'm going to place the weight of the plank itself right at the center of the plank. That's where F of G needs to go. So there's F of G plank, and that's going to equal to the mass of the plank, which is 30 kilogram times G. And then as you do torque problem, it's important that you identify where the pivot is going to be. So the pivot for this particular problem is going to be where this contact force is exerted by this level surface onto the plank just as it rotates. Okay, so I'm just going to go ahead and label that pivot. So that's super crucial because then you need to measure stuff from the pivot. All right, so that green arrow that just came up, that is perpendicular to this weight, the F of G of the mass itself, and that is a length of 1.8 meters because that's given in the diagram. And then I want to measure my length relative to my pivot again. This right here though, this is only 1.2, okay? It's 1.2 because, well, this entire top segment is 4.2. The plank itself is 6, so F of G is placed at midway. Watch where my cursor is. So that's 3. Well, 4.2 minus 3 is 1.2. Or you can look from it from the right side. If I go from the mass all the way to the center of the plank, that's the distance to 3. Well, this is already a 1.8. So 3 minus 1.8 is also 1.2. So you can look from the left side of the plank or the right side of the plank. And this distance needs to be 1.2. So it's important that you understand which distance to use as you set up torque, okay? So once again, F of G here is pointing down the y-axis. This 1.2 relative to pivot is along the x-axis, so that is already perpendicular. So there's no angles to do for this one. So I'm just gonna set up torque in the counterclockwise equals to torque in the clockwise direction. You can do clockwise equal to counterclockwise. It doesn't really matter. The value will come out the same. All right. Well, what's causing this particular system to rotate counterclockwise? The weight of the plank itself will want to keep it rotating in a counterclockwise direction, while the weight of the mass will want to cause it to rotate in the clockwise direction. So therefore, I just put F of G times R because by definition, torque is just the force times the moment of arm there. Likewise on the right side. And then I'm just going to go ahead and expand this to equal to the values. Here, F of G, the plank is just mass times gravity. Once again, I kept that as G. And then what is the R for the plank? Well, the R for the plank from pivot to where the force is being applied, that is a distance of 1.2. On the right side, F of G of the unknown mass, well, simply it's just mass times gravity. And then the R, once again, is measured from pivot to where the force is being applied, and that is a distance of 1.8. As you can see, G cancels out. So ultimately, on the left side, you just have 30 times 1.2, and then to solve for M, divide both sides by 1.8 meters, and that's what I did in my work here. So if you simplify that on your calculator, you should get a value of about 20 kilograms, okay? All right, other than that, that is it for this particular problem. All right, stay nerdy, don't be wired.